can't simplify this fraction any further because 25 doesn't divide easily into 2 or 4, so we can leave that as our final answer. Okay? Pretty good? Okay, next two questions are extremely important. We're almost done for the day. So, but these are extremely important for the test. This first question does not look complicated, but for some reason, it always causes a lot of problems on the test. So I'm going to put star, star, star next to this question. Okay, x to the power of negative 3 over y to the power of negative 2. X to the power of negative 3 over y to the power of negative 2. Now, whenever you have a quotient like this, and so you have a negative exponent in the numerator and in the denominator, you don't have to do 1 over or use reciprocals and complicate things. All you have to remember is this has a negative exponent. It's in the top. It is going to move from the numerator to the denominator, from top to bottom. This has a negative exponent. It's starting off in the bottom, so it's going to go from the bottom to the top. So my final answer is going to be the x is now on the bottom, and it becomes x to the power of positive 3. The y is on the top, and it becomes y to the power of positive 2. That's all that happens over there. Now, what if I have another example, but I have x to the power of negative 3, and in my denominator, y is to the power of positive 2. Is the y going to move anywhere? Is the y going to move anywhere? Yes or no? What do you think? What do you think? No, it's not going to move anywhere, because the only time something flips or moves is if it has a negative exponent. Because the y has a positive exponent, it is going to stay in the denominator. Now, is the x going to move? Raven, what do you think? X, does it have a positive exponent or a negative exponent? Negative. If something has a negative exponent, does it move? Yes. So the x is going to move to the bottom and become positive. Okay? So the x is the only thing that's going to move. Whenever you have a negative exponent, it has to move. Alexi, if the x moves from numerator to denominator, what's going to be left in the numerator? 1. Very good. Never write the number 0. Just because x is leaving doesn't mean there's nothing there anymore. The 1 is always there. So if everything is moving from the numerator or the denominator, you still have to write the number 1. Okay? So this is why students get tripped up. They forget about the movement and how the movement happens. So this is part of the seminar you might need to watch a few times before you do your test. Okay? Let's do a question that is similar but different at the same time. This is another question that really deserves some stars. Okay, so I'm going to explain what students usually do when they see a question like this on the test. And this type of question will definitely be on the test, so you really pay attention to this, okay? What students usually do is, oh, here's a negative exponent, here's a negative exponent, here's a negative exponent. I'm just going to start moving up and down, blah, 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 and then I'll be done. But really, we have something in brackets. We have common bases. So can this be simplified first? Because we have common bases? Yes. We should be able to apply my exponent rules. Am I applying my exponent rules for multiplication or division? What do you think? Division. Good. So first of all, You can't forget where your foundation, where the simple rules that we began with are. So I'm going to keep my base the same, my base x and my base y, but be very careful now when you are applying the rules, because now we have negative exponents, and this is where people trip up. So I have a negative 2 minus, whenever I have more than one sign, two signs next to each other, you have to put a bracket around it. Negative 2 minus negative 5. I have positive 3 minus negative 2. So it never hurts to write everything out. Don't try to do it in your head, because you may lose marks after making a careless mistake. So x, y, I can rewrite this as negative 2 plus 5 and positive 3 plus 2, because the negative times the negative is a positive value. And my final answer is x to the power of 3, y to the power of 5. So no flipping up and down required. All we had to do was apply the basic rules. Okay, let's do one more question before we're done. Now this is a question which is very straightforward. This is our last question of the day, but this is going to be a typical test question, and there's a lot of combination and applying the rules more than once, okay? So write this question down carefully. Okay, so first we do have a few negative exponents, which I want to highlight and always bring a highlighter to your test, just to remind yourself that that's negative. Sometimes when your brain sees it or your eyes see it on your test, it doesn't register to your brain that it's negative. So really highlight that when you're doing your test. So because I have two monomials in my numerator, I want to get to a situation where I only have one monomial in my numerator and one in my denominator. So first thing I'm going to do is combine my numerator, okay? So we're going to leave the denominator alone. And so remember, we're looking at like terms. My 5 and my 8 are a like term, so I'm going to multiply 5 times 8. My next set of like terms is my x terms. So I'm going to keep the base the same and add my exponents. 4 plus negative 6. Same thing with my y terms. Keep the base the same, and I'm going to add the exponents. 7 plus 2. Okay? Doing everything very carefully and very slowly, because the second I screw up on one little exponent, it'll throw off my whole answer. So my new numerator is 40. X to the power of 4 plus negative 6 is going to give me negative 2. Y to the power of 7 plus 2 is 9. All over 10 x to the power of negative 7 y squared. So now I have a monomial in the numerator, monomial in the denominator. I can see that these are common terms, these are common terms, these are common terms. They have the common base. So I can go ahead and divide. I have 40 divided by 10 When I'm dividing, am I going to add or subtract my exponents?